Hello, listeners. Welcome to the second episode of the Unlocking the Energy Trilemma podcast with our hosts, Ravi Krishnan and Jose Martinez. They are experts in the energy sector, and they will help us to understand the reality of energy transition and the hidden tips to achieve it. Jose Martinez is the CEO of edX, an artificial intelligence company for power generation, and a business expert of the European Union on the energy sector. He is based in Madrid, Spain, and works internationally. Ravi Krishnan runs a global energy industry marketing and consulting firm based out of the United States, and is also very active in Europe and in Asia. Ravi supports many customers on energy transition and decarbonization. In this episode, Ravi and Jose have met at Madrid, and they are debating about the present and the future of hydrogen. Ravi, over to you.
Jose, nice to see you again.
Nice to see you and welcome to Madrid, Ravi.
It's been excellent to be back in Madrid. It's so much more warmer than it is in New York. It's a nice sunny day here, and we are here to talk about the energy transition again. And as many of you may know, we started off this podcast series by talking about the energy trilemma. Today, we are going to talk about the use of hydrogen as a key enabler for the energy transition. Jose, what do you think about hydrogen? Is this the key enabler that we've been talking about? What are your views about green hydrogen?
Okay, thank you, Ravi. In my opinion, hydrogen will be one of the main enablers in the energy transition, probably not the key enabler. And it will depend on three factors: the cost and availability of generation of that hydrogen, the required transportation of that hydrogen, and its final use. And it will depend on the country, it will depend on different conditions, which will help to become that enabler. What do you think?
Exactly. I think the use of green hydrogen is largely on a case-by-case basis. In some countries where there's abundance of renewable energy, low-cost renewable energy, low-cost nuclear energy, the production of green hydrogen becomes much more cost competitive and economically justifiable. In addition to the fuels, the access to the renewable fuels, one also needs access to low-cost, efficient electrolyzer technology for all of this to be put together. So this is largely on a case-by-case basis, the production of green hydrogen. And again, the uses of green hydrogen are obviously abundant. It has a definitive impact. If you can produce green hydrogen in a cost-competitive manner, it can definitely have an impact on your decarbonization programs. However, the key question to be answered is the accessibility there to produce green hydrogen. Are the conditions optimal for producing green hydrogen on a case-by-case basis? And as you will talk more about, is the availability of efficient pipeline transportation network.
I think that's one of the key limiting factors regarding the transportation. There are several reports that show that transporting hydrogen is 2.5 times less efficient than transporting electrons. But even being less efficient, I think it's very complementary, and in some cases it could be very useful. Europe, for example, is building the hydrogen med of the Mediterranean Sea, and there will be a huge pipeline coming from the south of Spain to regions such as France or Germany, where the hydrogen will be produced in Spain or coming from the north of Africa and will be consumed in the northern Europe for industries or even power producers. We have to fix that problem. We need to invest, we need permitting, we need years to make it happen. But once it's done, it could be a very good solution for many uses.
Exactly. And the availability of incentives and other programs are also key. For example, in the United States, the Inflation Reduction Act has been playing a huge part in accelerating the evolution of hydrogen as a fuel for both electrification as well as industrial use and for mobility. So the availability of incentives could be a great enabler, as we are seeing in the United States and in many parts of the United States, to ensure that a project is actually viable. Now, Jose, with respect to incentives in Europe, are you seeing any programs similar to the IRA or any progress made with specific tax credits or incentive programs with the...
Not similar with the IRA, but Europe is pushing forward the collaboration, the public-private collaboration. That's one of the ways. And the second way, there will be some funding of these huge projects from a geopolitical perspective, trying to avoid the gas from Russia and similar, or having to import natural liquid gas. There will have some funds and some subsidies in a similar way that it happened a lot of years ago with the original renewables in the beginning of this process.
Yeah. Let's talk about the use of hydrogen in power production and the limitations and the limiting factors. What are some of the trends that you're seeing in Spain? Are there projects that burn hydrogen, even if it's a blend?
There were some projects. Unfortunately, some of them have been cancelled because the amount of hydrogen required, even it was only a 30% blend, it was very high, and we didn't have such amount of green hydrogen yet. But I think we'll need some years to make the technology more available, and especially the green hydrogen more available in different locations. Probably we are producing green hydrogen in the south of Spain with a lot of sun, but we need to transport it to the north of Spain where this power plant is. So there are some limitations with the transportation. Even the production of the hydrogen is, let's say, cost effective. Okay? And how do you foresee the storage, the use of storage of hydrogen?
Yes. Hydrogen as a potential enabler for storage could have a tremendous impact on ensuring that renewable as a resource can be a long-term solution for the energy transition. One of the big factors for renewables today is as it's intermittent. And when it's intermittent, you often cannot avoid the redundancy of baseload assets that have a carbon footprint. Now, hydrogen, like several other technologies, offer a lot of promise for energy storage. However, the key is going to be whether it could be a long duration solution to complement renewables. And secondly, how efficient it will be and how cost competitive. Again, it's going to be on a case by case basis, and a limiting factor there would be access to fuels that can potentially produce the green hydrogen.
Yeah, I remember CAISO, California Independent System Operator, is reporting daily the amount of renewables that are curtailed. So they are sent to the trash bin because there are not room for them in the mix. And I think that they could be dozens of gigawatts hour per day. And I think this is a great opportunity to use them, convert them into a long storage system such as hydrogen, and reuse them at night or next day or next month. So I believe hydrogen could play a fantastic role in helping or reducing the curtailment in grids with high renewable percentage.
Excellent. So I think what we are coming to a consensus is that there is a lot of promise with hydrogen. Of course, it's on a case-by-case basis.
Mm-hmm.
Key enablers are going to be the access to low-cost fuels, renewable fuels, the availability of incentives, and the seamless permitting of potential pipeline transportation issues that could potentially delay the evolution or the adoption of hydrogen on a widespread basis. Again, the availability of incentives remain a very key factor, and certain markets that have access to incentives, such as the IRA, are seeing more rapid progress with hydrogen. The other interesting factor is that many of the retired coal plants are being converted into sites where one could potentially commission a sizable renewable energy plant that can eventually become a site for production of green hydrogen. So there's a lot of homework to be done. It is not an immediate short-term solution. We did not even talk about at length about the uses of hydrogen for industrial purposes. Green hydrogen, if produced cost effectively, when combined with nitrogen, can produce green ammonia, And when combined with carbon capture, either through the DAC process or potentially through the point source process, can produce a range of methanol and its derivatives. And in the short run, we are seeing a lot of projects that are evolving with a number of industrial and chemical companies eager to have access to green hydrogen so that they could potentially produce these green chemicals and make them available. Do you see any of those activities happening here in?
Yes. I think the industrial use of hydrogen, I think it's one of the low-hanging fruits. And in Spain and Europe, this is probably the first use of hydrogen, or the key use of hydrogen. And for example, in Spain, the gas network operator has made a call of interest to understand in 2030 the amount of hydrogen that could be produced and the amount of hydrogen that would be demanded. And there is a good match, and we could produce even more hydrogen to be exported to other countries. But definitively, the first use will be industrial, then probably burning a high percentage of hydrogen instead of natural gas. And these are the two factors that will be limiting or enabling the energy transition.
Excellent. So this has been a great discussion, Jose. Thank you very much for your input. This is our second cast on the energy transition topics, and we will be in the coming weeks and months talking about a number of other energy transition topics, ranging from grid software to grid modernization to electric vehicles, carbon capture, the use of AI and ML for the digital transformation, and a whole range of technologies out there that can potentially accelerate our quest for decarbonization. Thank you very much to our audience, and we look forward to seeing you again. Thank you.
Thank you.
We hope you liked this conversation. In the next episode, Ravi and Jose will interview a well-known expert in the industry to help us unlock the energy trilemma. Follow us on LinkedIn or subscribe in the podcast platform of your choice: Spotify, Amazon, YouTube, or Apple.